Yeah, I mean, we talked about everything in there, but it doesn't really mean we're done with it. Oh, yeah, okay. All right, guys, so do you want to do another example we just did, or we totally can? All right, because we are actually going to end up doing another problem like that in a minute anyway. We're just going to start a little bit before where we started here.
Are we going to do the ones that are kind of like that, but it's like a circle?
Yeah, we are going to do what's called Conic Sections.
But I remember there's like a specific formula
for circles and ellipses.
Yeah, that.
Yeah. So what's really cool is you start to notice a pattern. So with lines, there's a certain form you can put a line into where you can see the most important aspects of the graph of it in the form of the line, right? Before you graph it, mx plus b. You can see the slope and the point, right? Where does it start? Where does it go from there, right? Those are the two most important things of a line. Are you with me? With vertices, with parabolas, if you put that in the right form, I can see the vertex, and I can see if it opens up or down. You guys kind of with me? And that vertex is just about the most important point on that thing. So if I put it in the right form, I see something important about its graph. Circles will eventually see, for a circle, what do you think are the two most important things to know?
Radius?
Yes. I love it. The center and the radius, because it tells me where to start and how far to go out from there in all the directions.
The diameter.
Well, the diameter is nice, but I need the radius, because that's related to the center. So if you put the circle in the circle equation in the right form, the center just pops out at you and the radius just pops out at you. You can just see it, just like mx plus b. Which makes sense, because if I'm graphing from the equation, I should be able to see something about the graph in the equation because they're related to each other. That's exactly what we're seeing right now with quadratic formulas and their graphs, parabolas. You put it in the right form, I can see the vertex, I can see if it opens up or down. I guess, does just that make sense? Yes?
Yeah, I didn't really get how you can tell if it opens up or down.
Oh, it's just positive or negative. So this one opens down, right? And if I had made it positive, it would have opened up.
And if it didn't have a number right there, if it was just x minus 1 squared.
Well, then it's positive. So if I have this function, what's the number in front?
1.
Positive 1. So it's going to open up. It's positive. If it's negative 1, it would actually have a negative show up. I like it. So
If there was a 0.
then it wouldn't be a parabola. I love you. So if I had 0 times, who really gives a shit? What's 0 times anything? 0. So then you just have a h of x equals 7. And that would just be a flat line at 7. Wah! I like it. So 0 is a little too extreme. It's sort of like if the slope is 0. You just have a line like this, right? Sort of the same idea. I like it. So if you go a little too far, you totally lose your variable, and then it's just a constant, just a flat line. Poor little thing died. Okay. So even if you didn't want it, we are going to get more practice with what we just did, bless you. But we're going to have to start. I don't know if you picked up this about math or not, but we learn something, and then we go, oh, there might have been a few steps before where we started. And of course, we do that for a reason. We want you to understand this shit, and then we go, oh, what if it looked like this? How do we make it look like this? Because then we know what to do from there. We do that all the time because it makes the most sense that way. Every now and again, math people can be nice. So this is coming back for this. Let's remember how this works. Some of you guys missed this lecture. Maybe you don't know what the shit this means. Does it mean like you have these many sides and you have to just complete the square? I did it. No. So just by itself, how would I use this to solve using this? Of course, that would give us a -7 and 2.
Take the half of -7.
Yes, and what's up? Yes, cool. So the first step is you take half of -7. Second step is you take whatever you got and you square.
Yeah.
I think part of this, again, most of you guys were here for why this is true. But then you kind of forget it, and then you're just like, it's extra shit to memorize, it's magic bullshit, it's what he said to say. But we saw exactly why these are the steps we take. There's a reason behind this. You got to remind yourself of that reason every now and again. So what does this tell me?
Put it up in the equation.
Yeah, that's what goes here, and if I put it there, I better put it there. And then what does this tell me?
X minus.
What that's gonna factor out.
That's going to be how this factors. That kicks ass. I don't actually have to do the factoring. It's already done for me. Now, of course, this is assuming this is a 1 here, right? Okay, how we doing so far? Okay. And over there, I have to get LCD, 8 and 49, 57. All right, so I just want to remember how that, and then you square root, add the 7 halves over, blah, blah, blah. I don't care about the answer. I just want to remember completing the square. That's what it is. Now, second little thing we have to know going into what we're about to do, see if this can make some sense. Let's do this, let's see. Oh, let's do this. 2 times 8 is 16. Ooh, look at that. That's like the most people ever. That's that answer. If I add 1 to 8, does that go up by 1? No. What do I get? 18. I like it. So if I have something like this, let's see if you guys can get this. If I complete the square on the inside, half of 4 is 2 squared is 4. So I need to add 4 right there. If I put a plus 4, do I just put a plus 4 on the other side also?
No.
Of course not. Because I put a plus 4 inside, like I put a plus 1 inside here. But what did I really just do to this side of the equation? I multiplied it by, I added 12. So if there's a number out front and I change the inside, the actual change is that number times what I did, because that's what's really going on, just like here. The actual change was 2, not 1, because it's being doubled. I like it.
Previous teachers didn't show like the simple version of that.
You know where I'm
It makes
going.
A lot more sense.
All right. And then one extra little tiny thing. Let me see. Do I want to do that right here? Maybe. Okay, let's do this. So this is related to Raiders of the Lost Ark. Somehow. Now, he doesn't do it correctly. He obviously didn't. His character in the movie. Archaeology and all that kind of great stuff, but I don't think he took enough algebra. Because, do you remember the scene? Now, if you've never seen Raiders of the Lost Ark, that's your homework. Good Lord. But do you guys remember where he has a golden statue and he has this bag of sand, right?
Yep.
And he tries to, what's he doing? He's going to take something away, so he has to add something at the same time, so the overall he didn't do anything. And if it worked, if he did it correctly, if he balanced his stuff correctly, Bowler ain't coming out. But Bowler came down, oh shit, and the whole thing. Right? And the people that throwing spears that have just as good aim as stormtroopers and all that kind of stuff. So what the hell am I talking about? Let's do a problem. I'm going to show you where that last thing comes in. It's a little bit wonky to try to make a situation. So here's what's happening. I know the form. I haven't written it down yet, but just to show you, we know this form of a pail of water, a form of a quadratic. That's the most useful is this form. A times x minus h squared plus k. Now that looks freaky as shit. But if A is positive or negative, that tells me it opens up or down. H and K tell me the vertex. There you go. So A greater than 0 up, A less than 0 down, A equals 0. Flat line, we don't look at it. And then vertex would be at HK. So that seems to be a very useful form to put stuff in. So here's an example. If I have f of x equals, start off nice. This is really, really nice. This is exceptionally nice. This is like, that's insultingly nice. All right, Jeff, forget it. So the hard part about what we're going to do is everything is happening on one side of the equation, because this is not really something I could do something to. Are you with me? What's f of x minus 1? So I'm going to try. Now look at the idea. I want to make it look like this, and it don't look like that right now, right? But we have a process to make it look like that, which is the completing the square process. That's what makes it look like squared, right? That's why I call it complete the square. So how do I complete this guy square? Half of 6, and then square 3. So what goes here? All right, so I'm going to add the sand, add the 9. At the same time, I better take 9 away so that I've done nothing. So again, the traditional way of thinking of an equation is a balance. If I add 3 to one side, I better add 3 to the other side, or else it's not a balance. It's not true anymore. But I can also I could add a weight of 3 on one side and take a weight of 3 away, and it's still balanced. So if I do this, if I do that, have I changed that side of the equation at all? Have I made it a different number or something? No. It's really if I said, what's 7 minus 1 plus 1?
That's a hard one.
I mean, you're like, what the shit? 7. You just undid what you were going to do.
Oh, yeah.
So if I add 9, subtract 9, I just did nothing. Way to go, Jeff. But I have made it look different. What can I do with these? That's the complete of the square thing, right? How does that piece factor? How does this factor? Whoop. Now 1 minus 9? So what's the vertex?
-3.
Let me see who can see this. What's the y-intercept? 1. Yes. Why use this freaky ass form? If I make x 0, I get 1. This is this is this. So if I want the y-intercept of this, I can just go there. Bam! This is the beautiful form for y-intercept. Because when I make x 0, I just get whatever the hell numbers at the end. So the y-intercept is 0, 1. So then I can graph this thing. Let's do this graph real quick. And then we'll do a more gross one. Need grammar much? Yes. Oh, it's got to be over here. Be smarter than that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Of course, this sucker is going to open. How's it going to open? Up. That's right. like a house with the balloons and all kinds of. So the vertex, -3, -8. 1, 2, 3, 4, 5, 6, 7, 8. That's why it's always good to number those things, but. Y-intercept 0, 1. So where's there going to be another point? 1, 2, 3. 1, 2, 3. And then I'm done. You can do whatever sound effects you want. All right. Not too bad. That wasn't too bad at all because that was a 1 here. Yes, sir.
Wouldn't you move over 3 and then down 8?
-3, -8. So -3, -8.
Oh, okay.
Yep.
Alright.
All right, let's do another one. All right, let's do this one together. It's got some tricky parts. Two things I have to do. One thing is very slight. I'm just going to make some room. So I'm going to put my -2 way over there. The other thing is completing the square only works when the first number is a 1. I can't divide by 3 because I don't really have another side here. So I just take a 3 out of only this piece. Left some room in there. Poor little 3 dude. Your poor little 3 dude. 3. There you go. So you guys might realize this, the second thing we looked at was 3 outside. So whatever I put on the inside ain't gonna be what I did. Oh, that was a good sentence. How do I complete this guy's square? Should be relatively easy, right? Half of -4 is -2 squared is 4. So I gotta add 4. Now what did I actually just do? I didn't add 4. And you're all like, dude, I just watched you write a +4. What did I actually do? Added a 12. So I better subtract a 12 at the same time. Because is that really a -4x? Is it really a -4x? No, it's a -12x. Everything in here is triple what's in here, isn't it? So if I put something inside, I have to triple it and see what I really did. I just added 12 things of sand, so I better take away 12 things of gold statue. So then I get 3, how's this factor?
X -2.
Yeah, because the first step was half of -4 is -2. So the vertex is where? 2, -14. The y-intercept is?
0,
-2, I like it. And it opens up, because it's +3. So, you know, if I go to graph this, I can be smart about my scale. Why do I want to be smart about my scale? Because I got to have 2 -14. I don't want to. I don't want to do that. So I can go, and you want to. I can at least do it by 2's, right? 2, 4, 6, 8, 10, 12, 14. And then here's where people get a little freaked out. Yes, sir.
Still a little blank on how you get the y-intercept. Like, I get everything else. It's just
How do you always get the y-intercept? You make
the x0.
x0. So if you make x0, what do I get?
Alright.
Yeah. Now watch. If I made an x0 on this one, this is this. 0 minus 2 is negative 2 squared is 4 times 3 is 12 minus 14 is still freaking negative 2. But that took me a little longer than just, oh, I see a negative 2, right? So that's the idea of all of these are the same function. So it doesn't matter which one I look at to get information. They're all the same. Which one do I look at to get the vertex? Not this shit. This is the best one for the vertex. Which one do I look at for the y-intercept? That one, because I can just see it. Yes?
On the test, when you ask what would you ask us? Like, on the test? Like,
Everything I'm saying. Yeah. And I got one of these handouts has got pretty much the exact same format. It'll be on the test or quiz. By the way, real quick, before I forget, quiz. Monday. Section 10.7 through, what was it I was thinking about? Yeah, 11.2.
Okay.
That's bad. That includes quadratic formula, so if you haven't memorized that yet, you should get it memorized. Right. It's not the most important thing at all, math at all, but just memorize it. Oh, let's make a scale. Here's the thing I was about to say. This scale can be totally different from this scale. Of course it can. You've seen this shit all the time.
Mr. Johnson, let's see, in 2001 and 2002, we made $1 million and $2 million.
Totally different scales. Jeez. So I don't understand when somebody was making like, this was by 50s, and they went this by 50s, and the graph was all freaky as hell. I'm like, no. I just have to make this 1, 2, 3, negative 1, negative 2. That scale can be all Fisher Price because all my stuff is happening 0, 2, right? Maybe I want to go to 4. All right. So then my vertex 2, negative 14. My y-intercept 0, negative 2. So where's there going to be another point?
Negative 2? No.
1, 2.
No, 4,
1, 2. So 4, negative 2.
Yeah.
Or a little 4 do. Okay. Miss a point, make it big. There. Yes.
So really, all you really need for our purpose is 3 points.
Yeah, 3 at the end. So you really just need to find 2 points. Their computation. The third is through the reflection. And then you connect them because you know the shape. The better you know the shape of a given function, the less points you need to graph it. If you don't know the shape at all, you might need like 10 points because you're like, I don't know where this thing turns and all this shit. Yeah. Okay. But we know the shape, so we just need like 3 points. Okay.
And if our lines aren't exactly perfect, so we won't knock us down points. Like if they're like,
Oh, please. Yeah. They don't have to be exactly perfect. We're doing it by hand. In fact, when they're perfectly perfect, I'm a little concerned. Right? That they didn't really come from you. Maybe they came from the calculator. Okay. So let's see. You guys try these two that are on this 11.7 that's on the back of the 11.6. Example 1, example 2. More of these. So just make sure everybody's doing the right ones. It's the one that says x squared minus 6x plus 10. That's the first one. piece of the vertex is. That's the axis of symmetry.
Oh, okay, yeah. I don't know.
That forces it through the vertex. So here the axis of symmetry would be x equals 2.
So the key things you want is to graph this. No, when we actually, like, if we were to take a quiz on this.
Yeah, so
Here.
I would ask these questions.
Okay.
And really answering them, getting enough information like that. Yeah. Notice I'm not asking you to graph these, okay? I don't know if you guys are doing that. Don't do that anymore if you do. This one's a little tricky. Very, 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 very careful in a couple places because that negative. Let's see. Poor little dude. So in this one, what do you add and subtract? 9, 11. Half of -6 is -3. And then when you square that, you get 9. So you're going to add 9, and you're also going to subtract 9. So that overall, you did nothing to that side. Go us. Now, this though, the reason we did nothing is we made it look different. Factors like what?
X minus 3.
Yeah, x minus 3. And over there you get
Plus 1.
1. So the vertex,
1 and 3.
3, 1. I like it. What else did I ask for?
Axis of symmetry.
Yeah. Does it open up or down?
Up.
Up, because it's positive. And axis of symmetry,
0 and 10. Oh, wait, wait a minute. That's the blind percent.
that's the y-intercept. X equals 3. Be careful. Axis of symmetry is a line. So the answer to that has to be the equation of a line. X equals 3. It's a straight up and down line. So what's the axis of symmetry always? For an up or down parabola, it's going to be x equals the x part of the vertex. It's going to force it to go right through the vertex, which is where the mirror should be. So, any questions on that one? I see a lot of quizzical faces, but nobody asking.
Can you show us, like, can you draw it out too? Or
Okay, sure. Let me see if I can't. Sorry. Do a little one. What was oh. The y-intercept is 10. You see that? So we do 2, 4, 6, 8, 10. The vertex is 3, 1. 3, 1. So another point would be where? 1, 2, 3. 1, 2, 3. Right there. Mirror image of that y-intercept. Yeah. Woohoo. What can you tell me about the X-intercepts?
There's the X by vertex.
No, specifically about this one. Can you tell me anything about the X-intercepts? Some of you guys, well, if you look at the graph, are there any X-intercepts?
Oh, no.
But of course, that's wrong because we only graphed the real numbers. We didn't do anything with the, complex numbers. So since there are no real x-intercepts, if I set this equal to 0, I would get complex answers. How can I see that very quickly? B squared minus 4ac would be 36 minus 40 is negative. I'm going to get negative square root. I'm going to get complex answers. Oh, shit. Well, that's what it means. When it has no real roots, it must have complex roots, which are the answers to this equals 0. How are we doing? I love the little concern in your faces. Come on, you could do this. Just how many answers does it have to be to this equals 0? It has to be 2. Do you see any real answers to that? No, there's nowhere that it goes through 0. It starts right up here and it keeps going up forever from there. It's never going to hit the x-intercept, x-axis for the real number, so it must be 2 complex answers then.
Before that, what would you say no solution? Or just
Yeah, before section 10a, I think it was 10a, we would have said not real is what I was trying to say. Yeah, I think the book says does not exist, which is really evil. I hate that shit, because of course it exists, we just didn't know it yet, right? And say somebody doesn't exist just because I haven't met them. That'd be weird. What are you talking about? Doesn't exist, never saw them. What about this one here? What's the first thing I would do here?
factor out 3x?
Yeah, factor out, not a negative 3x. I'm not truly factoring. Why was this one easy? Because this piece had a 1 coefficient. We just moved the 10 out of the way, right? Does this piece have a 1 coefficient? No. So I'm going to take out a negative 3 so that this piece does have a 1 coefficient. What do you get when you take out a negative 3? Minus. That's the first level mistake people make.
So you want to keep the x squared?
Oh shit, yes. Because we're not factoring that. We're not factoring this. We are taking something out so that there's a 1 coefficient in front of our x squared. That's the whole purpose.
Okay.
Why are we doing anything to this? Because why didn't we do anything to this? Because there's already a 1 here. I need to force there to be a 1 here, so I take a negative 3 out. That's it. Whatever's in front of the x squared, you take it out of the first 2 things. The last number just kind of moves over, gets out of the way. Like always. We always just moved him out of the way when we're doing completing the square. Yes?
Did you use the original one and you have it?
Hell no. No. Completing the square only works when there's a 1 here.
No. When you're gonna take the half.
We're going to take a half of what?
I don't know, is it the 12 or the
That's what I mean. In this expression, was there a 1 first? So I can't use this for completing square. Now that I made a 1 here, I can use this. So when I take half, it's going to, of course, be half of this. So the first step is half of negative 4 is negative 2. Second step is square negative 2. Get 4. So what I'm going to put here, plus 4, what did I actually just do?
subtract 12?
I subtracted 12, so I better
Add 12.
add 12. Negative 3. How's that factor?
X minus 2?
X minus 2 squared plus 4. Let me pull this up here. You know, like, do whatever you want to, man. Oh, shit. That's when the earthquake hit. Oh, cool. All right. Let's see. So what's the vertex?
2 and 4.
2, 4. How's it open? That is a 50-50 chance, right? Opens down. And somebody tell me, if it has a vertex at 2, 4 and it opens down, will this one have real x-intercepts? Because it starts above the x-axis and goes down. So it will hit the x-axis. What was wrong with the other one we just did? It started above the x-axis and it went up. It went away from it. It's like it's never going to hit the damn thing in the real plane. What was the other thing? Axis of symmetry. X equals 2. Boom. And if you want a quick graph, I'm looking at all my stuff. 2, 4 down so I can make nice normal. 1, 2, 3, 1, 2, 3, 4. So 2, 4. What's the y-intercept? Where was the beginning? What's the y-intercept? Oh, of course it's that. What's the y-intercept? Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh boy. So where's there going to be another point? Please don't give me shit about that being curvy. Yeah, so 1, 2, 1, 2. So over here. Boop. Make big. Why is it kind of skinny? Because it used my fitness pal. No, because it's got a 3 out there, right? It's going to make it go down fast, right? If it was negative 1/3, it would have been wider. Coolness, yes.
So the X-Intercepts is 1 and 3.
It looks like it from what I did here. How would I find the X-Intercepts?
Shift it over? Wait, no, no.
That's a great question because we're about to do this anyway. How would I find the X-Intercepts for that?
Y equals 0.
Good. So then that would mean that negative 3x squared plus 12x minus 8 equals 0. So a lot of you guys would give up on poor little factoring. If you divide everything by negative 1, you get 3x squared minus 12x plus 8 equals 0. Does this factor 3 times 8, 24. Are there factors of 24 that make 12? 2 and 12 would make 14 or 10 or something. They don't make 12, right? 3 and 8 don't work, obviously. 4 and 6 don't work. There is none. So then what are we allowed to use then? You could have used it. Quadratic formula. So what would it be? X equals 12. Negative b, right? Plus or minus square root. What's 12 squared?
144.
Minus 4 times a times c all over twice a. 12, give or take, square root of 12 minus 90, 144 minus 96, I believe. Oh, what would that be, Jeff? 48. All over 6. This is shit you're going to have to be able to do yourself, by the way, so not just Jeff going on. Well, let him go. We're giving us numbers. No. 12 plus or minus 16 times 3 is 48, so I get square root of 16 is 4. All over 6, and then you can, let me do this. 2 plus or minus 2/3 rad 3. Now, what do you notice that's interesting there? Do you see how that's saying start at 2 and go up 2/3 rad 3 and go down 2/3 rad 3? Do you guys see that? That's what that says. 2, give or take that much. So start at 2, go up that much, go down that much. That's how you get the X-intercepts.
Is there another way to solve it?
Yeah, you could do complete and square.
Like we did.
We could have taken, now here, let me show you. We did complete a square here, didn't we? So you could have done this. Negative 3 times x minus 2 squared plus 4, set that equal to 0 right there. Subtract 4, divide by negative 3, square root, add 2, and we get the same place. Same answer. Believe it or not, it's the same answer, because how do you rationalize this? Multiply by rad 3, you get 2 rad 3 over 3. Yeah, so either way, I like it. I wanted to remind you of quadratic formula, because you got it on that quiz coming up on Monday. Okay. So, last thing. Looking at section 11.7. Notice this. I'm going to take all this away. I'm going to overanalyze something for a minute, like you guys think I always do. So, everybody got this here? Oh, okay. All right. Give you a rest there. Poor little dude. Let me see. That's not a good one. Wait, let me make one a little bit easier to start with. You can do it, Jeff. Can you do it, Jeff? Yes, you can. There you go. Look at you go. I want to do several things to this, and then I'm going to develop a beautiful shortcut out of this. Help me find the X-intercepts of this thing. Hell no.
Not quadratic formula.
What would you try first, of course? Especially, does it factor? How do you factor this? So what are the X-intercepts? I like it. Now, so that means this parabola hits right here and right here. Can somebody tell me then, what is the X piece of the vertex? Doing no more work than I've already done.
4.
It's got to be 4. If I know the intercepts are here and here, the vertex has to be right in the middle. The vertex is in the middle of everything in the parabola. Whatever 2 points I see, it's got to be in the middle of it. That's how we were getting that third point every time we got a third point from the mirror reflection, was using that idea. They got to be equidistant from the line through the vertex. Oh shit. So when the intercepts are nice, that seems to be a great way to do this, Jeff. But when the intercepts are gross, you might go, well, then I don't want to do that, Jeff. But here's the beautiful thing. How would I find the X-intercepts? Let me finish this one out. Let's double check what we just said. I'm going to put this into standard form real quick. I'm just going to do it a little bit quickly. It's exactly what we've been doing. Completing a square. Half of -8, -4 squared is 16. So add 16, subtract 16. Sure enough, what do you get for the vertex? 4, -1. Which makes complete sense because it's got to open up. And it is right in between the two intercepts like we predicted it would be. It has to be. It wouldn't make any sense for it to be over here, or like over here, and what's it do? No, we can't do that weird shit. So how do I use that to make a shortcut? Because I don't want to complete the square every time. That gets really gross. Especially on something like this one we just did, right? There's got to be a better way. So Travis, coming back to what you said earlier, that I just shit all on when you said it, but you suggested quadratic formula, but what is the quadratic formula again? Because what does a quadratic formula do? Why would I use quadratic formula here if I forgot a factor? Because it accomplishes this. It finds the X-intercepts. So here's the quadratic formula again. Let me write it a little bit differently. This is related to what I was just talking about earlier. Can you guys see that what this says is whatever negative b over 2a is, it's going to go up by this much. And it's going to go down by the same exact amount. Do you guys see that? No? Yes. Please tell me you do. because it's right there. Start here and go up that much, start here and go down that much. So what is right in the middle of those two intercepts then? Yes, but be much more specific with what I've got up here. Negative b over 2a is. Of course it is. If I said start at 7, now add 3 and subtract 3, what's right in the middle of two numbers you get? Do you have to get the two freaking numbers? No, it's going to be 7. If I start at 7, add 3, subtract 3, what's in the middle? 7. I don't even care what the numbers are, right? Maybe. If I said start at 11. Now add the square root of 39.8 and subtract the square root of 39.8. What's in the middle of those? Freaking 11. It doesn't even matter what that is. I know it's going to be 11 in the middle. And why is that important? Because that's where the vertex is. That's where the x piece of the vertex is. So this right here, x equals negative b over 2a is the shortcut. Make a word out of that, Joe. There you go. So find the x piece of the vertex. Now once I got the x piece, how do I get the y piece? Plug it in. Always, right? Let's try an example. What was that one we just did? It was negative 3x squared plus 12x minus 8 or something, right? Was that one we just did?
Yeah.
Yes. So if I use this shortcut, x equals negative b, what's b?
12.
12 over twice a. Negative 12 divided by negative 6 is 2. Was that the vertex x piece for that we got? What did we get for the vertex for that one? Oh, we
2, 4.
just did.
2, 4.
So then how do I get the, so that's the x piece of the vertex. Please, dear God, don't stop there because the vertex is a point. How do I get the other piece? I plug a 2 in. Negative 3 times 2 square plus 12 times 2 minus 8. Negative 12 plus 24 minus 8. 12 minus 8. 4. Sweet. And this is a lot quicker than computing the square. Yes? No.
What's that called?
The shortcut to finding the x piece of the vertex. There's no short word for that shortcut.
Oh, I
Sorry.
thought it was like a method that you were using. So it's just a shortcut.
Yes, just a shortcut. Yes.
So on the test, you specify which method to use.
Yeah, I would. If I don't specify, I would hope to God you would do it this way. If all I want is a vertex, do it this way, right? So now, if I had to graph this function, if I just said graph this by finding the vertex and the y-intercept and another point, I would do this. I got the vertex and the y-intercept staring me in the face. Quick, really nice, quick. Plot the vertex, plot the intercept, get the third point by the reflection thing we've been doing. Kabam. Okay. Why does it make sense, by the way? Putting it into standard form, I used completing the square. Finding the vertex quicker, I used quadratic formula, really, right? And isn't quadratic formula a shortcut to complete a square? So it's a really nice thing that makes sense there. I'm like, all right, shortcut involves a shortcut for the thing. How about that? Usually. Blah, 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 blah. Blah, blah, blah. Okay. So here, find the vertex. Oh shit, I just took it away. Well, you hopefully wrote that down. Find the vertex for this. This is on that sheet. 2x squared minus 16x.
Sheet 2x squared minus 16x plus 25, right?
Yeah. Find that vertex. Yeah, I think that's pretty good. Oh no, oh god. Okay, I'm sorry, Boca. Sorry, you're fine. Don't think that wrong. You don't have to use completely square on this one for sure. You use the shortcut we just developed. Yeah. Don't complete this guy's square, please. Please don't.
But that would have been right?
Totally, it has to work, but I don't want to do that.
For when you plug in the -16, does it become positive?
Yeah, well, it's negative b. So let's see, negative, what's b?
Negative 16.
All over twice a. So it becomes 16 over 4. So then how do I get the y piece? I'll plug a 4 back in. So I'm going to show you a little something. This is kind of silly, but just in case you pick up on this, I use this all the time. 2 times 4 squared is 2 times 16 minus 16 times 4. You do not have to look at it the way I'm about to say, but if you get what I say, it's really cool. 2 16s minus 4 16s is negative 2 16s, which is negative 32 plus 25 is negative 7.
I didn't get
2 16s minus 4 16s
it. Okay.
is negative 2 16s, which is negative 32 plus 25 is negative 7. Or you do each one, 32 minus 64.
Oh, okay, I get what you're saying. Minus the 2.
Negative 32 plus 25, negative 7. Bam. So what's the vertex?
4 and 7.
4, negative 7, love it.
Okay, that's good.
Become a